Right. The last type of problem I want to talk about are actual chemistry calorimetry problems. The first kind was just, okay, I've got a piece of metal. It's heated from this temperature to that temperature. I could solve for Q. I could solve for M. I could solve for specific heat. The second type of problem, something hot is putting heat into something cold, one way or the other. This is the third type of problem. We have a reaction occurring in an aqueous solution, or we are dissolving something and making an aqueous solution. If we have two solutions that are being added together, we would first, and this assumes we're starting with a reaction, we would have to figure out how much, when I added these two solutions together, let's say I had a sodium hydroxide solution and I mixed it with a hydrochloric acid solution. We did something like this in class on Saturday. The problem that we did, I think, had 0.1 molar. It was 100 milliliters. Well, let me not do that part yet. I had 0.1 molar. I had 100 milliliters of it, of 100. Oops, go back to this guy. 100 milliliters. Let me get myself sig fig there. Of 1 molar sodium hydroxide. I had 50 milliliters of that. And I had 100 milliliters of 1 molar HCl. I had, why am I saying I had 50 milliliters when I just said I had 100 milliliters? Let's get rid of that. Okay, so I had those two things. I was going to mix them. I think the problem told us that the specific heat for the solution would be the same as the specific heat of water, 4.184 joules per gram degree C. And let's see, what else did we need? We got mass. Okay, we had a T initial and a T final. And I don't remember what they were, but I think the delta T here was 6.7 degrees C when they were combined. And so what we were trying to solve here was delta H of the reaction. What I can measure is the effect of the reaction on the solution in which it occurred. The reaction that occurred was HCl and NaOH forming NaCl and H2O. Okay, that's the reaction. But this thing's aqueous, this thing's aqueous, this guy's aqueous. That's a liquid. Those molecules of water that are formed are liquid. You will see the water in here. Okay, there is water as a product, but there's not a water as a reactant. It's just everything is happening in water. These are solutions. So the first thing we had to do was figure out how much heat was gained by that solution, Q of solution. The mass of our solution was, okay, and somewhere in the product, it would tell, in the question, it would tell you the density of this solution is 1 gram per milliliter. 100 milliliters of this guy, 100 milliliters of that guy. That's 200 milliliters. If density is 1 gram per milliliter, that's 200 grams of solution. The specific heat was 4.184 joules per gram degree C. Delta T was 6.7 degrees C. And I've got to figure out how much heat was absorbed by that solution. Let's see here. Bonk. Dude. 200 times 4.184 times 6.7. 5607. 5,607. I know I don't get 4 sig figs. I'm really only going to get 2 at the end. Joules of heat were absorbed by the water. That meant that the heat given off by the reaction was the opposite of the heat absorbed by the solution, the heat absorbed by the water in which the reaction occurred, which is negative 5607 joules. And so finally, this one I'm not doing another Q equals MC delta T because that's not the question. The question was what is delta H of this reaction? I'm going to put that number into kilojoules because delta H's are usually given in kilojoules per mole. So this will be negative 5.6. I'm going to go ahead and knock it down to 2 sig figs kilojoules. And I'm going to divide by mole of reaction. Okay. Because remember, the delta H out here to the side, it's for 1 mole of HCl, 1 mole of sodium hydroxide, 1 mole of sodium chloride, 1 mole of water. In this, if I had a limiting reactant, I'd go with the moles of the limiting reactant. I don't. These guys are the same. So I can just put that divided by 0.1 moles. And that comes out to negative 56 kilojoules per mole. I actually kind of think the reaction ones, unless they give you a complicated limiting reactant thing, I think the reaction ones are probably easier than the dissolving ones. So we did a dissolving one in the review session Saturday morning, so I'm going to make another video where I put up that free response. We pulled up an old free response. I'm going to put up that free response and go through it with you.